Okay, so today we are going to be talking about domain and range, as you can see. So when we talk about domain, we talked about this a little bit last time, but it was just with ordered pairs, right? But domain is all your x values. So that's what's happening horizontally on your graph. That's what's happening from left to right. Okay? It's only concerned about left and right. It's not concerned about up, down, diagonal. It's just what's happening if it's going left or right. Okay? And range is all your y values. Okay? So that's what's happening vertically. So what's happening up and down. Okay? So what we're going to have today is we're going to have a graph. And it's going to ask us to figure out what the domain and range are. Now, last time when we had like a set of ordered pairs, we had to set up like each x and y value separately. So, like for example, we'll look at this one first. I'm going to zoom in here a little bit so you can better see. But this time, instead of giving the actual ordered pairs, it gives me dots. Okay? So because these are not continuous, like a straight line here, we have to list each x and y value separately, just like we did last time. So if I'm finding the domain, I'm finding all the x values. So basically, everywhere there's a dot, I'm going to list that x value from left to right. Okay? So if I go to my leftmost dot, I have one here at -6. So -6 is my least x value. And then the next least one is right here at -5. So -5. And then there's one at -2, at -1. And then the next one's over here at 3. And then I've got a one over here at 6. And then I've got to put my squigglies on it. Squiggly brackets. Okay? And then you do the same thing for the y values. So you go from bottom to top, least to greatest, right? The least y value is right here at -6. Next one's at -4. And then I've got one at -1. I've got one at 2. One at 4. And one clear up here at 7. And then I've got my squigglies. Squiggly brackets. Okay. So this should look pretty similar because it's basically what we did on the last assignment, right? And then for determining if it's a function or not, you just got to make sure that there's no dots on the same x value, which there aren't. So yes, this is a function. Okay? Now, that's what you do when they're ordered pairs, when they're dots. We have to list them as individual points because they're not continuous. They don't have any x values in between these 2 points, for example. But if it's a line, this line includes all the x values between -2 and -1, right? So like -1.5 would be on that line, -1.1, -1.0000001. So all those x values are on that line. So we can't list them because that'd be like an infinite number to list. So what we're going to use, and I told you it'd come back around, is interval notation, right? Interval notation is that fun thing we did with inequalities, where you did like the least number, and then you had like a parenthesis or a bracket, and then you had like the greatest number, and then like a parenthesis or a bracket, something like that, right? So the least number in the interval, greatest number in the interval. And depending on if it was equal to that final number or not, used a bracket or a parenthesis. If it didn't quite equal it, you used a parenthesis. If it did equal it, you used a bracket, right? Well, we're going to be doing similar things. Okay? And also reminder, if it was ever like negative infinity or infinity, you can never equal those, right? So those always had parentheses. Always had parentheses. Okay? So let's look at this one. So domain. Again, domain is all your x values, right? So I'm just trying to figure out what's happening from left to right. Now I'm going to zoom in here a little bit. Just so you guys can better see. Like this line has arrows at the end, right? Arrows means it keeps going. It keeps going that direction forever, right? And it keeps going that direction forever, right? And I'm exaggerating the diagonal nature of it, but it is going up and to the right a little bit, right? It's still going right as it goes off that graph. So because that arrow is there, it means it's going to continue to go slightly to the right forever, okay? And this is going to continue to go slightly to the left forever. So if I'm trying to figure out the domain of this graph, okay, I'm trying to figure out how far to the left it goes and how far to the right it goes, because domain is just left and right. I don't care if it's going up or down. I just care if it's going left or right. So as this line goes off the graph, it is still going slightly left. And since it keeps going slightly left forever, if I go slightly left forever, I'm going to go to the negative infinity, right? It's going negative forever to the left, and negative forever to the left is the negative direction. So it's going negative infinity. So its least number is going to be negative infinity. Okay? And this one is going right, or slightly right, forever, right? And since that's the positive direction, going right forever, forever means infinite, right? It's going to positive infinity. And since these are infinities and you can never equal infinity, they would have parentheses. Okay? That's the domain. Now, that was left and right. Now for the range, I'm trying to figure out if it's going up or down, right? So as we look at the graph, it is going obviously down as it goes off the graph forever, right? Because it's got the arrows. And it is going up as it goes off the graph forever. So same idea, negative infinity to infinity, just this time on the y-axis. Remember, these are two different sets of numbers that we're talking about, right? This is negative infinity on the x-axis. This is positive infinity on the x-axis. This is negative infinity on the y-axis, right there. And then this is positive infinity on the y-axis. So, again, we have two different sets of numbers, your x and your y values. So while these are technically the same thing, they're representing different things. This is forever to the right. This is forever up. This is forever left. This is forever down. Okay? That's what that is saying. It's going, basically anything with a diagonal line is going to go forever, in that right or up or whatever direction, right? It's going to go both horizontally and vertically if it is diagonal. Okay? And then determine if it's a function or not. We do a vertical line test and it only hits the line once. So yes, it is a function. Okay, let's try another one. So let's look at this one. So, domain. Again, that's just your left and right. Okay? As we look, it has an arrow going off here, but it stops here, right? So arrow means it keeps going that direction forever. So it is going left forever. So left is the negative infinity direction, right? So its least number is going to be negative infinity. And its greatest number, it's always its most positive number, is going to be right here at 4 on the x-axis. So 4. So infinity always has a parenthesis, but it does hit 4 here, so we're going to put a bracket next to the 4. Okay? It does include 4 right there. Okay? Range, same idea. We're going to go, but again, instead of going left, right, we're going to go bottom, top. Its least y value is right there where it starts at 3. It looks like that's 3, right? So 3 would be its least y value, and it does equal 3. Okay? And then as we look at this line, it is still going slightly up as it goes off, right? Slightly up. So it's going to go slightly up forever, so it's going to go slightly up to slightly infinity. Okay? And that would be your range, right? Again, this is left. This is as right as it goes. This is as down as it goes, and this is as up as it goes, right? And then for function, vertical line test, it passed the vertical line test, it is going to be a function. Okay? Now this one is hard to see. Like, I'm having a hard time figuring out just looking at it, but this is a box. Just right here is my box. Box, box, box. Okay. So now you got a shiny box on your screen. Is this better? Do this and it works. Oh yeah, that's much better. Woo! Boy. Okay. All right. So, domain. This is, again, we're just concerned about how far left it goes, how far right it goes. So its least x value is right here at -2, right? And it does hit -2. It's right there on the -2, so that is a bracket. Okay? Again, if it even looks like it hits it like it generally is going to be a bracket, parentheses are going to be mostly for horizontal asymptotes, if it's an exponential equation, and for infinities, which by the end you're going to be mostly parentheses because it's mostly infinities. By the end it's unit. Anyway, so -2 is the least x value, and then the greatest is going to be 5 right here. So 5, and that's going to be a bracket as well. So again, least x value, greatest x value. Okay, left most value, right most value. Okay, and then range is just bottom top. Least y value is 4. Greatest is 6. So 4, 6 in the brackets. Okay, and again, leftmost number, rightmost number, downmost number, upmost number. Okay, and then is it a function? If I draw a vertical line, it hits it twice, right? That's not a function. No fun. Okay. And I think that's pretty much it. So if you guys have any questions, comments, concerns, let us know. We're here to help. We want to help, and I will see you guys out there.